We have a nice group of people here from WebTrends, so we're going to have a Q&A at the end, so love to talk to you guys more about what you're doing and what we're doing with some pretty interesting technologies. I had a fortunate opportunity to speak at the Hadoop Summit not too long ago. Briefly talked a little bit about this if you guys were down in San Jose. But we're going to start, give you a little story about what we did. WebTrends is a 20-year-old software company. It's a company that's been around for a very long time. A lot of you guys may have worked at companies that had an IT group that used WebTrends originally with their log analyzer product. It basically collected Apache web logs or sensor data or sets of information that's coming in through your network information stats and turned on it and reported on it. It was a pretty simple, traditional software package that you would install locally. We've gone through a lot of change since then, and it's been really targeted towards a SaaS operations solution, and we host a SaaS platform that lets our customers interact with us. But being a 20-year-old software company and having a lot of companies convert over to our SaaS platform in, what was it, when did we launch WebTrends Live? In 2000 it was about when it started. We have a lot of data since 2000. And if you think about that, we collect a vast majority of the WebTrends internet traffic, like from Microsoft to large banks, insurance companies, travel companies, and this data is big. When we talk about big, we're talking about billions of events and transactions per day that we're collecting through our tags collection systems. And originally, we were dropping this all into big file stores, right? Big SAN, Hitachi systems, very expensive, very large network-attached storages. Now, moving forward, yeah.
So I'm confused. You don't own that data, right?
That's correct. We don't own the data. We are stewards of it for our customers. So we collect all this data for our customers, and we store it into this big data stores. Well, guess what? Fast forward to now, we have this new thing called Hadoop. And Hadoop is allowing us to collect this data and process this data much more efficiently. Everybody understands, probably have heard of Hadoop. Hadoop is it's not a small thing, but it has lots of projects. And one of those projects that works with Hadoop is Spark. It's not part of the traditional Hadoop ecosystem, but it's a project that works very closely with the Hadoop infrastructure. This is a great comic. If you haven't seen it, it's really fun. But it's one that we went through, and maybe many of you guys have gone through too. When you're dealing with big data, there is a concept that it comes with a cost. But guess what? That cost is much more palatable than, say, having to deal with big data at a large Hitachi systems. If you just have to talk to my boss here, who's VP of Engineering, he would much rather write a check for commodity hardware than writing million-dollar checks for big network-attached systems. So that said, Hadoop ecosystem and things like Spark is a very appealing concept for developers and for companies to deal with this types of data. We had to go through come to terms with it that we're going to have to bite off this bullet to build this infrastructure that's going to let us process all this data. I mean, we're talking, we have 2,000 clients, 13 billion transactions per day that we're processing. We're collecting vast amounts of data coming in at very high speeds that we have to turn around and process. And one of the things about 5 years ago, we sat down and said, okay, we got to change the way we're doing business because it's not going to really work with the way that people want to see data anymore. People want to see data in real time and a ad hoc analysis. We need to be able to do predictive capabilities on this data sets. We have lots of things that we need to do and expose to our customers that our old system was just not supporting. So that made us really realize, and we had to do this surge, and we started developing a new platform, and it allowed us to go to a new product that we called WebTrends Streams. WebTrends Streams is an ability to take data as we're collecting it in real time and pass it back to our processing centers in about 40 milliseconds. This is a critical part of our product to be able to move data quickly, because if we don't move that data quickly, we're not going to be able to return it and report on it and analyze it quickly. We have lots of attributes that we have to collect: gender, products, SKUs, you name it. And we have to turn that data around and report on it. In addition to reporting on it, we actually have to present relevant content to customers. Marketing customers, like offers, presentations, abandonment emails. So if you're buying something and you don't want it, we need to be able to retarget those customers with that data. It's as it happens. All this data is being ingested and processed into our Hadoop infrastructure. So this was about 4 years ago? Yeah, about 4 years ago we did this. We realized that that was a critical step for us to do because we needed to get that data into our infrastructure quickly. Originally, it was a batch process. It took like 90 minutes. And customers don't work on 90-minute windows anymore. So what does that mean? I alluded to this. We have 2,000 clients that are running on our SaaS operations platform. We have 6 data centers around the world. We have to collect this data from those data centers within 40 milliseconds from the time it hits our servers to the time it gets back to our main processing centers where we have Hadoop infrastructures. We process over 13 billion events per day. So we move this data, but now what are we going to do with it? We're getting it in. We're dumping it to legacy systems. We're still producing log files. We're still producing these large data sets, but we need to be able to make it expressible and expose it to our customers. So the next big thing that we had to do is like, well, you know what? We're taking all this data. Now we need to dump it in Hadoop. Right? We originally wanted to get the transportation done, which we did. We're leveraging, we'll talk about technologies here in a second. I just try to get you a story. But we were leveraging Kafka. If you guys have used Kafka or heard of Kafka, it's a very superior data transport system. It lets us get it back to a processing center really quickly. And then we're now writing it into Hadoop. So the next thing that we worked on was something called WebTrends Explore. And WebTrends Explore, I got my marketing videos here going on. Basically takes the stream data and joins it with the historical data. Right? Now we have the ability to look at the full entire lifecycle of a customer, the visitor, the event, the sessions that they interact with the sites, all being stored in partitionally, highly distributed data sets into our Hadoop infrastructure. And this data allows us to take action on it both historically and in real time. So you're thinking, well, 13 billion events a day, or processing 13 billion events every day. We collect gobs of data. What do we got to do? Well, we have these really awesome servers called Dell R730XDs. If you guys want to know it, they're a great commodity-based hardware Hadoop infrastructure, if you haven't ever looked at those. We have 3 petabytes of HDFS data that we're storing. We have 64 million files in that structure. We have 86 HDFS nodes, and we have 61 Spark nodes that are running our queries that we access that data through. And that, when we talked about Kafka, we have 14 Kafka nodes that are moving this data across all the different data centers. Oh, and to do this, you got to have dual 10 gig. Like as Denny was saying, 10 times faster, you need 10 times more the network bandwidth. And really, that does make a difference. I think we've just made it blip a little bit. It's kind of fun to try to really cause that little utilization light to flash on your switch. It's pretty challenging. But it's not one that we're willing to not tackle. So we talked about this. Data, huge amounts of data. We have all this queries. We have all this information coming in. We have this visitor information. And everybody talks about big data. We got our Hortonworks rep back there. So if you guys want to deal with Hortonworks and works with good old big data, talk to Ward right there. He's in that jacket right back there. Ward has been a great advocate for us in helping us with getting our data hats on. But one of the things that we do, that we talk about is, data is big, right? It's a lake, it's a marsh, it's, whatever you want to call it. Everybody's probably heard that data lake term getting thrown around. Guess what? I don't call it that. I call it a sea of data. This is a great quote. I'm not going to read it necessarily, but it's a Jules Verne, 20,000 Leagues Under Sea. This is the way we look at data in WebTrends. It's vast, it's expansive, it's infinite. We don't control and constrain what the customers see and how they actually interact with our data. They send us anything. We don't have any constraints about what we can be receiving. We can receive sensor data. We can receive website data, mobile phones, Internet of Things, right? Think of your Apple Watch now, right? Biometric data, GPS information. All this information is being collected about people. We are in a very data-rich world, and Hadoop is the ecosystem that's powering that today. And now, this is great, but how do you get to the data? How do we make this accessible? Well, you ask how, right? Well, the cool thing about that is we have technologies like Spark, and that's what I want to talk to you about today. I needed to give you a little bit of history there just because the amount of data that we're talking about is not small. You can't run it on a laptop. You could run an hour, or I mean, Sean and I are like, we basically just take an hour of data and that's what we test with because it just doesn't work. Ethan's shaking his head, yes, it just does not work. So this is a quick technology stack, and you can probably, I'm not going to go through it all, but our optimization platform and our measurement platform is what we're talking about. Spark is a critical part of that, and that Spark component is what we do to expose and make that data accessible through our APIs and our applications and reporting. And we're going to talk a little bit about how that works and why we need that to work the way we do. There's basically 3 types of ways you can access data, right? Most people will probably recognize these, well, 2 types, but we've made a 3rd, let's call it that. The first type is, streaming, right? We talked about that. We put that originally in our system. We have the data streaming through. We have Spark streaming out there. You look at streaming data sets. You bring up a window of data. You're processing that window of data. You're counting it. It's like a good analogy is a fish in a barrel. You put your head in the barrel. You look down and you count your fish. That's your data that you're counting. But if you lift up your head out of that barrel, you're missing your fish, and you don't necessarily know what's going on, right? You don't have the ability to necessarily go historically. You only observe what you see, right? That's great for some applications. Streaming is really quick for rapid evaluation. Is this working the way you expect it to work? Is this doing what you want it to do? Spark streaming is great for that with the windowing and the capability of doing the checkpoints and consuming off of Kafka and processing this data, right? Sean is actually one of the PMC members who's here, and we'll talk about it with him in the panel, but he originally wrote the Kafka adapter for consuming for Spark streaming, or at the time of dstreams. So it's very resource friendly. You can run this on a single laptop. You can spin one of these suckers up, ingest data, process it, count it, look at it, do whatever you want with it, and it just works. It does have the issue of error, right? You are only observing what you see, so you have to make probabilistic decisions about what your potentials could be if you're not observing all data points. And there's issues with latent data. Well, if you observe something, but that data didn't get into the pipeline at the right time, maybe it's out of order, you have to deal with that. So there's different concerns and questions you have to ask when you're applying yourself with Spark streaming and streaming technologies. I wouldn't use it as a source of record. We've had customers try to do things with source of record with this. We just dealt with an escalation dealing with the customers having to be backfilling this data sets in. It doesn't work necessarily as a source of record when you're dealing with streaming processes unless you have some way to checkpoint these things. And it is the quickest feedback loop. Everybody gets that, right? You're seeing this data. It's happening within 40 milliseconds. It's the best way to get information back. And if you're looking for trends and potentials, it's a great way to do this, right? Well, that's option number 1. Everybody's probably going to guess what the next option is, and that is the good old batch process. I kind of equate this into the batch process, and if you see the mailboxes behind this image, Sean and I were talking in the office today, and we were saying, the closest to a batch is like ordering something on Amazon, right? You got 2-day primes, like prime shipping, that's awesome. Until they get the drone delivery, you're still only, you're ordering it, you think it's going to be good, but when you get it, damn, it's not what I wanted, right? I got to return it, do it again, and you got to wait another 2 days to get it show up. That's your batch processing. That's the best analogy to batch processing because you think you want it, you think you got it, but it's not necessarily one. We had a guy that just ordered some of these really cool wireless headphones, the not Beats, but they're like some Chinese-made version of them. They got 2,000 likes or reviews on the Amazon Prime. And he's like, that's great. It can answer phone calls and can listen to my music and do all this stuff. And when he went to try to use it with his Mac, his PC, and Windows 10, it just didn't work. It's like his feedback loop was crappy because it was a batch process. Like he ordered this thing and it didn't show up. So it gives you a lot of flexibility because you can ask anything of the data, but it's not necessarily the most responsive from a feedback loop standpoint. It can be used as a source of record, right? You can actually use this information because it's going to be entire data sets, right? You have the full thing to look at. You can look at any data window you want to look at. You can look at any parameter list. I think my batteries are dying. And but it could be resource intensive. If you're doing large data processing, batch processes, you have to shuffle a lot of data around out in Spark. It's going to take a little bit of time potentially to process and crunch these numbers. So what did Webtrends do? We have this streaming technology coming in. We have all this data being processed. We needed a third option. We can't do one of these things. We can't make the customers wait a long time, and we can't make decisions for customers that don't have all their data. So we needed a third option. So what we did is we built something called Webtrends Infinity. It's a marketing name, but I'm going to let you know what it means. It's an approach that we basically use streaming analytics over ad hoc data. So it's a combination of using, with the high expressibility, using non-shuffled data sets. And if anybody knows embarrassing parallel data structures, we're moving this data, we're not having to move this data around because we don't really care about where it lives. It's partitioned across these data nodes, and we're able to ask individual data sets questions about this data and query it out in real time using Spark and stream it out through to our customers or through to the APIs that we need. We don't have to do the shuffles because we're trying to keep the locality close to the data because we're preparing it and landing it in using the streaming technology in a format that's more susceptible for querying. So this gives you a little bit of knowledge about how you're preparing your data, but at the same time leaving it unbounded from the flexibility standpoint. So we don't have to do the batch processing, but we still have all the parameters and the abilities to query this information. So because of that, we had to use and leverage some of these streaming algorithms, like hyperlog plus, Countman Sketch for certain high cardinality columns, tdigest, and scalable boom filters for doing visitor segmentation and understanding different filtering and reduction of data sets. So, saying a lot of words, just watching time. All right, so we had this world before where we had these traditional data stores, right? We had EDWs, right? You had the data set, we do a batch transform, put it into a container that looks like this, and we had to plan our schemas properly. You had to make sure your questions that you were asking was formulated properly. You could use Spark on top of that. Spark SQL is great for that, right? Structured data, as Denny was saying. You have all this data that's being very structured, and you can then query about it. That's what Hive, a lot of people are doing. Oh, let's put Spark on top of SQL, and SQL, let's connect this all up. It's great for looking at these structured data sets. With the new stuff in 1.6 and some of the things that we had to actually add because we needed to have unstructured. We don't know the number of parameters that we're going to query. We don't know the size of the data that the customer is going to send us. We needed some way that we could use a more modern data architecture. And that modern data architecture allowed us to use partial aggregates from the RDDs and the data frames and being able to look at that data and say, okay, this group of data, the green section, right, is the data that's related to this customer, and let's take that off and take that out and take that fragment and then throw it in a cache like HBase. Leverage that data now and don't have to reprocess that information. The partial aggregates can be stored off, right? We can use those again. And then we can use it like a journal. So we just keep on pulling the data out, caching it, storing it, adding more. Pull it out, cache it, store it, add more. And then as long as you use the same caching algorithm, you can reference that data and not have to query it off of the source data again. So it's creating a very high, quick response rate for returning to data out of Spark, but at the same time allowing us to still access the information and have flexibility in our questions that we're asking of the data. So let's see it. Let's talk about it. So Sean's going to pull open an interesting little demo that we have. And then click on the window. It's hidden right now, Sean. Click window. Oh, there we go. So, so what this is an API, and Sean can talk briefly about this, but it gives us the ability to express, it's not SQL, but it's a monadic, sorry, I can't say this word, monadic expression across our data set that basically has very similar expressibility in Spark and in Scala. So we're asking here, we're looking for all page view, give me counts of page views, product views that had a product view, and count the number of visits that the person had. And I think it also has revenue tied into it based off of the sessions. So as you can see, the data is growing and drawing in. This is being returned out of the partial aggregate stores across all the different Spark nodes in our production environment, reading the data sets, and as the partitions are finishing, this finish bar is adding and is streaming it back out through a WebSocket. That WebSocket then is drawing those data sets and doing these aggregations on the fly. It's not using Spark streaming. It's using just standard good old Spark with basically a REST interface on top of it, or actually in this case a WebSocket interface, and streaming that out. And this is doing all this on the fly, and that's going real time against the data set. And this was, I don't know what that was, a day? 50 million records that we just queried and did these aggregations on. So it's not a small data set, and it's not something that we're, pre-caching. This was not using a cache. This is going raw against the ORC files. So if anybody knows about HDFS. Can you flip me back to my presentation, Sean? You might have to minimize Chrome or just close it. Thanks. That's it. Good. So that's how we're using SIF to express data and query data, right? So that's a lot of data that we're exposing, giving the user a lot of power to be able to express that information, leveraging these different streaming algorithms, and letting us use it through Spark. So in addition to that, we have all this data being collected. A lot of times the customers need to know where this data is coming from, right? And who are these visitors? What is the visitor? What are they doing? How's the traffic showing up? And we're collecting this based off of, we have the idea of an event. We have an idea of a session. We have the idea of a visitor. And a visitor is like, a person that uses many different devices. They have many different sessions that they interact with the website on. And they have many different events that are actually happening. So with this, we have to be able to target data based off this segment. So we talked about this from a streaming standpoint. So this data is coming in at a high rate. We need to be able to make decisions on this instantly and take this from a streaming concept. So Hello Kitty, everybody likes Hello Kitty, right? Does this lady like Hello Kitty? No, she doesn't like Hello Kitty. What about this guy? Maybe, actually. I don't know. But they say no, they don't like Hello Kitty. Of course, Hello Kitty. It makes sense, right? Well, taking content like this and being able to take action on that is really important. So our streaming infrastructure, as it is coming in, we have streaming processing, streaming agents that can be listening as a streaming service in Spark Streaming, looking at this and finding out the different types of attributes that need to be assigned for the different events that are coming in. So these are the different aggregations, like one visit, one view. This is the landing site, the people that came from home. They didn't have a traffic source, meaning they just probably went to the site directly. What type of browser did they have? And we determine these different mix of attributes and create a contrast set mining data set. And we'll have lots of different potentials based off the attributes that are coming in. If you really think about it, right, if you consider all this information, you have 15 attributes with 6 values. You're talking about quite a bit of different combinations of different rules that you could generate for this data. So, well, we use a tool that looks over the entire data set, and our solution was this automated segment discovery. So we take all this data that we've collected, all these attributes, and when you start using Stucco and different algorithms, that actually start pruning this data of irrelevant rules and actually determining significant segments based off of some objective. So if the person was to purchase something, this is a segment based off of these attributes that we see in the data. Let's assign those to as a segment that we want to target. Let's give Hello Kitty to that person, not everybody, right? Not to the punk rocker or whatever it was. So it creates an output of a list of contrast sets and presented for the data and be able to make targeting rules based off of that for marketing decisions. Another thing that we're doing is we're spending a lot of time using LDA. And we use LDA to determine different actions and types of classifications for these parameters. As we mentioned, we collect thousands of parameters for each customer. And we don't necessarily know what those parameters are for, right? So the idea here is that we can say, here's somebody that added something to the cart. Here's somebody that made a purchase. Here's somebody that signed up for some form, right? These are actions and topics and classifications that based off of those classes, we're assigning these parameters that are like for those different actions. So add to cart is XYZ parameters and purchases ABC parameters, And when we see these things, we're creating these action sets. And what we're trying to do is predict the next 5 actions that the person's going to do based off the streaming data that's coming through in the system in real time. So we're saying, okay, well, this is an action that we don't care about because they didn't see anything. Here's an action that they did, like add to cart. Oh, they have a propensity to do X, Y, or Z in the next coming actions if we see these types of behaviors based off of historical trainings that our models are producing, right? Again, it's things that Spark streaming and technologies like Spark can allow us now because we can do these aggregations in real time as they're going through our data systems. So here's an example. So a person comes in. The down one here is the purchases in the next 5 actions. This is at least one add to cart action in the next 5 actions. So the person comes in, they hit a landing page, they clicked an ad, they looked at a list view and a product view. Not likely to purchase, but their probability of adding to cart just went up, right, in the next 5 actions. They clicked on some links. Probability is kind of staying stagnant, still having, more product views, not really adding to, not probably purchasing yet. Oh, they added a cart. When they added a cart, guess what happens? They're most likely going to maybe buy something. So we're predicting a higher probability of purchase. We could be using this information to make better decisions for marketing purposes and providing customers feedback in real time, like offers, free shipping. You can start thinking about these opportunities. Abandonment emails. Oh, they started clicking through and they're still clicking links. But their probability to purchase is falling off because they're still doing activity, but they're not really actually buying anything, right? They could be just window shopping. Oh, well, now it's really falling off because they started looking back for more products, maybe doing more searches. Not necessarily a good trend for somebody actually to purchase something. Maybe we need to engage with this customer. Let's present them an offer. Oh, look at that. We presented them an offer. They went in there and clicked view cart because they saw this offer and they should go view their cart. They added a promo code maybe or something. Their probability to add more items to the cart obviously went up, but obviously as you get closer to the checkout funnel, the probability of purchasing is much higher. So again, using this feedback loop in real-time data sets that were coming in through Spark streaming from Kafka and all their data processing is obviously a really critical indicator of some of the things that we can do with our data.